Alright, this is the day 1 lesson in our unit where we're working on solving systems of equations. And we've learned so far 3 ways of solving systems of equations, and they are graphing, and we learned about substitution, and we learned about elimination, which is also called linear combination. Alright, those 2 things mean the same thing, linear combination or elimination. So this homework just gives us 3 examples of, it gives us an example of each one of these ways of solving a system. So problem number 1, let's solve this system by graphing. So to solve by graphing, we just need to get y by itself. So let's take the first equation. So we have negative 3x plus y is equal to negative 7. And to get y by itself, we would just need to add 3x to both sides like this. So that's going to give us y equals 3x minus 7. Alright, so now this equation is ready to graph. To graph an equation, the easiest thing to do is to start with the y-intercept, the negative 7. So that tells us that the line is going to cross the y-axis at negative 7, so put a dot. Now the slope is 3, which you can think of as 3 over 1. This is rise over run. So that's going to be up 3, right 1. So starting from the y-intercept, if I go up 3, right 1, that'll be on the line. And I can keep doing that. Up 3, right 1. Again and again and again. I can even put 1 point going to the left by going down 3, left 1, like that. Okay, so these dots show me where the line is going to be, and I will go ahead and connect those dots by drawing a straight line through them. Alright, so there is my first line. Alright, now look at the other line, which is this 2x plus 2y is equal to 10. I'll change colors though. Again, I need to get this y by itself, so I'm going to subtract 2x from both sides like this. Alright, so that's going to give me now 2y is equal to negative 2x plus 10. So to get y by itself, I need to divide by 2 here, here, and here. So that's going to give me y equals negative x plus 5. Notice these 2's cancel out. Alright, so now this equation is ready to graph. Again, 5 is the y-intercept, so let's start there. There's my y-intercept. Now I need the slope. There's an understood 1 here that normally doesn't need to be written. So you can think of this as negative 1 over 1. So that's down 1, right 1. So starting from the y-intercept, down 1, right 1 is going to be like this. And you can see right now where the 2 lines meet. But let me follow through. And I could put more dots over here following the same pattern. Okay, and again I will draw my line. But this time I'll make it a green line. Alright, now the solution of the system when you graph is going to be the point where the 2 lines meet. Okay, so the solution is right here, and it is the point 3, 2. Alright, in other words, x is 3 and y is 2. Another way of saying the same thing. Alright, so that is how you would solve a system by graphing. Now, notice that number 2 is actually the same problem. We're just using another method, substitution. So here's how substitution works, but we should get the same answer. X equals 3, y equals 2, 3 comma 2. Now, for substitution, I recommend writing the two equations side by side. All right, just helps you stay organized. So we have negative 3x plus y is equal to negative 7. That's one equation. And then we have our 2x plus 2y is equal to 10. Now, this time we're just going to get one variable by itself. And it really doesn't matter if it's x or y, whichever is easier. And in this case, this y right here is going to be the easiest variable to isolate. Notice it is the only variable. We have an x and a y and an x and a y, but there's no coefficient other than 1. So that makes this the easiest. So let's go ahead and get that by itself by adding 3x to both sides, just like we did before. So that means we have y equals 3x minus 7. Now for substitution, once you have the first variable by itself, you're going to take whatever it's equal to and substitute that into the other equation where it goes. Since this is a y value, we're going to make sure that we substitute it in for y. So I'm going to take this and I'm going to substitute it here. Alright, now watch what I do. Whenever I do a substitution, I like to use parentheses for the substitution. So we have the 2x, I just brought that down, plus 2. Now I'm replacing the y with this stuff. But if I were you, I would create a parentheses anytime you substitute. And then go back and think of it as putting this in the parentheses. So I'm going to have 3x minus 7 like that. So now notice I have all x's instead of x's and y's. So this is an equation that I can solve. Let's go ahead and do the distributive property. All right, having the parentheses sort of reminds you that you need to do that. So this is going to give me, I'll just bring down my 2x. But then I'll have plus 6x minus 14 from the distributive property. Alright, we've got some like terms here, so that's going to give me 8x minus 14 is equal to 10. Time to add 14 to both sides. So that's going to give me 8x is equal to 24. You can get x by itself by dividing both sides by 8, like this. Okay, and of course, that's going to give me that x is equal to 3. Alright, so this is half of my answer. Alright, notice x equals 3. It matches what we got before. So we got the x value, but we still need the y value. Alright, so we're not finished with this. The way we get the y value is we take this x value and we substitute it in right here. So I'm going to take this x value and I'm going to substitute it in. Okay, so this is going to become y equals 3 times 3 minus 7. Again, notice how I like to use parentheses when I substitute. So that's going to give me y equals 9 minus 7, or y equals 2. So here I have x equals 3 and y equals 2, which as an ordered pair would be 3 comma 2. Okay, again looking back, 3 comma 2, same thing we got by graphing, and that should be the case if it's the same problem. Alright, the third and final method that we're going to talk about today is the elimination method, also called linear combination. Now, the key for the elimination method is that we want opposites that cancel. Opposites that cancel. That's what we want. For example, we want things like, if this is negative 3x, then I would want this to be positive 3x. All right? And it could be the x's or the y's. So you have to look at this and decide if you want to cancel out the x's or if you want to cancel out the y's, whichever is easier. In this case, it's going to be easiest to cancel out the y's because I see the positive 2 here. If I could make this into a negative 2y, I'd have opposites that cancel. And that would be very easy to do. All I would have to do is multiply. I guess I'll just keep it green. If I just multiply by negative 2, that will turn this into negative 2y, and I would have opposites that cancel. So this is what I have. This equation will become distributing. I have to multiply everything, including the negative 3 and the negative 7. So this is going to become 6x minus 2y is equal to 14. Okay? Now the other equation didn't change, but I would recopy it if I were you. So this is, I'm just bringing it down. So 2x plus 2y is equal to 10. Once you have your equations with opposites that cancel, we are just going to combine like terms like this. Now, we made sure that one of the variables had terms that were opposites so that they would cancel, and they did. Now the rest of this, combining like terms, we're going to get 8x, and combining these, I'm going to get 24. All right, you can see how it mirrors what happened in the substitution method. All right, and when I go ahead and divide both sides by 8, all right, for a third time, I get x equals 3. All right, which we knew would happen unless we made a mistake. And but we are not finished. We still need to find the y value. So the way you do that for elimination is just like for substitution. You have to take this and substitute it into one of these two equations. All right, you can use whichever one you want. Okay, I'm going to use the top equation. All right, so the top equation was negative 3x plus y is equal to negative 7. So if I take this and substitute, all right, I'm going to put it in for x right there. So this is going to become, I think I'll leave it like this. So this will be negative 3 times positive 3 plus y is equal to negative 7. So that's going to give me negative 9 plus y is equal to negative 7. So it is time to go ahead and add 9 to both sides to get y by itself. And that's going to leave me with y equals 2. So once again, I have x equals 3, y equals 2, which as an ordered pair would be 3, 2. All right, so that is just a brief overview of how you can solve a system of equations either by the elimination method, also known as linear combination, or the substitution method, or by graphing. All right, these were relatively straightforward problems. It can get more complicated than this when we have decimals and fractions, but this should get us started.